Okay, so now I need my supply voltage, right, and the ground down here. So again, I go to pick the component. So I'm pressing the insert button, and right. So for now, things like voltage source, your netlist label, like your pin label, and all those things, and current source. What else? The ground. You don't need you don't have them available, or you don't need to pick those ones from the PDK library. So that's where the scheme library comes in. So all those generic devices, you don't you pick them from scheme. Why those foundry specific devices? For instance, so those things you're going to be fabricating. For instance, I'm not going to be fabricating the voltage source. I'm just going to be using the voltage source for my simulation. That's it. So I can pick that one from a scheme. But if I know I'm going to fabricate anything, if I know anything would be part of my GDS file that I'll send to the foundry for fabrication, then I would have to pick such device from the PDK library. I don't know if you guys get. So for voltage source, I'm not fabricating a voltage source, so, and it's not part of a voltage source. The voltage source is not part of the CMOS inverter as a whole. Then I'm not going to be picking that from. I don't even think it's available in the PDK library. But for devices you have available both in a scheme and the PDK, so how do you know where to pick from? Just ask yourself, am I going to be fabricating? Is this part of the when you want to fabricate what you're doing, is it going to be part of that device? Will it be part of what you're going to be fabricating? So if no, you can just pick from the scheme library. Or another question you can ask, what is that device like inherently part of what you're designing, or it's just only useful for your simulation? So if it's just useful for your simulation, that's all it's playing, that's the role it's playing, then you just pick it from the scheme. So yeah, that's what we're going to do. So for voltage source, it's just for our simulation. When we want to do our transient, when we want to do our DC sweep, you need a voltage source to sweep. So you can just pick that from the scheme library. So I want to pick a voltage source. I'll just come to the scheme library. Then I can just search, instead of scrolling, I can just search for vSource. That's the keyword. So vSource, I click on it. Okay, then drop it. So I need two voltage sources, one for the VDD and the other for the gates input. So all I need to do is I just come here, I select, that is, I can just duplicate what I have already. You select by clicking on the device, then you go to your keyboard and just press C on your keyboard, C, then it get copied. Yeah, it's simple. I think I prefer shortcuts like this. Yeah, that's that. So now one of this will be for VDD, the other will be for the gate. So instead of me just doing a wire, so I can just come here, do a wire. I try to bring this to the VDD. I can do that. It's valid, but I don't want to do that. I'm just going to have wires everywhere messed up. I want my schematic capture, I want it to be clean, to look neat. So that's where netlist label come in. So you can just place, I can just place the label here and the label here, since I want VDD to be here. So I'm just going to do that instead of just talking about it. So first, let me just do a short wiring here. I stop, and let me just do for the two. Okay. and for this and okay, so all I just do now, it's since electrically I want this node, so this will be VDD, right? So you can just VDD should be 3.3 volts because global foundry, the voltage for the process is 3.3. you get max of that. You can use anything maybe a little slightly below that, but not exceeding the 3.3. For Skywater it's 1.8. so I'll just come here, I double click on that device. So for Skywater you want to be making it 1.8, right? But for global foundry I'm just going to be using 3.3 volts. So okay, so that's the VDD. And you know, how do I know the VDD? Where do you know to put the VDD? And you know, the arrangement matters. If you check the arrangement of the MOSFET, this is the PMOS. You can see source, the bulk, the gate, the drain. So for the PMOS, for the end CMOS inverter, the source of the CMOS, that's what is connected to the VDD. So that's why I ensured the source is up here. You get, for your case, if the source wasn't there, you have to flip it so that you have the source up there. Then the drain is closer to the power than the source of the NMOS and so on. So you want to also take note of that arrangement. Then so since I want this, so this is the VDD voltage source, right? So I want this node of this PMOS here to be electrically connected to this node, so without doing any physical wiring. So all I just need to do is to give them the same node labeling. I will label them the same way, so to the simulator they are electrically connected. You get, so again, the label we need, it's also a component, it's also an object. So you need any objects, you go to where you select components and you pick the object. So pressing the insert. So the label pin, it's not part of what you're going to be fabricating, right? So you just go to the NMOS. It's just going to be used for simulation, that's all. So you go to the scheme, you don't go to the PDK library. So I just go to this scheme library, not this one reading GF180 PDK. No, I just want to show. So I'll just go to the scheme, so which is this. I'll just click on it. So devices. So what I'm looking for is what is called lab pin. So this lab pin, this one, it's the same thing for Skywater too. It's just an scheme object, so it's same thing even on Skywater. So to rotate, I want this to be vertical. So to rotate, I think the shortcut is shift R. Then again, I want to move it down to this point. I ensure it's selected by clicking, just clicking on it. Then I press M for move. Then I connect. So I need this also here, right? I need similar thing here, but their labeling will be different. I need it also here. So I just need to copy. All I need to do is copy. So copy. I need it several other places too, so I'll just copy this multiple times. So you want to copy, you select by clicking, then you just C for copy, C, then it's copied. Same thing, C for copy and copied. I also need to label the output node. So first let me do a wiring here to just bring it out. So then C for copy. This time around I want it to be horizontal, so you do the rotate again, so shift R. Then I want to move it to this point. then make sure it's selected by clicking on it, then M for move on your keyboard. You press M on your keyboard after selecting, then you move it. Then lastly, so now you need to label them. You're just saying XXXX everywhere, so just you need to label the node. So this voltage source here is our VDD voltage source, right? So just click on the pin, the label, then you come here where you're saying XX, so whatever you want to label it as. So I call it VDD, right? So VDD, yeah, so let me, it's not showing fully because there's no space. Let me zoom out a little, so that will be Control Z. Yeah, so VDD, I also want this place to be VDD. You know, we want them to be electrically connected, right? So I edit this to VDD, so this way this node here is electrically connected to this voltage source here, VDD. Then this second voltage source, like I said, it's for our gates, the inputs, so I can just label this to be Vin. So Vin, right? And this node, this voltage source should be electrically connected to the gate of the CMOS inverter, right? So all I need again is the label. So I need this very label, right? So I just select it, C for copy, copied already. Maybe you want it to be horizontal, maybe you could just do, first there is no space here, let me just try to move these guys away. So you want to move a whole, like if you want to move composite objects, that is, like now you see this object is made up of the voltage source and this label pin. You get, you want to do that, you need to select everything at once to move everything at once also. So if you just select the voltage source, you just be moving the voltage source alone, but I want to move everything, so I just select, so how do you do that? You just try to drag your mouse over it. So you right click, no, you left click, and you try to drag your cursor over the area where the object is, and everything gets selected. Then again M for move, and it's been moved. So the same thing, drag, left click, hold the left button, then drag the cursor over the area to ensure the whole area is covered. What you want, it's covered, then it gets selected, then M for move, you move it. So I'm just going to be doing Shift R for this guy so that it can be vertical, horizontal, then I move it. Let's just do a little wire. Okay, so I still need some things here. I want to do some adjustments. So M for move, I just move this a little. Okay, so we need ground pin here, so this guys needs to be grounded, this voltage source needs to be grounded. Then, you know, for the CMOS inverter, the source of the NFET needs to be grounded. So from here you can see that. Let me show you so you can see it needs to be grounded. Yeah, right, it needs to be grounded. So let's do that. So again, ground, it's not really part of the whole fabrication thing. You're not going to be, when the IC is fabricated, there will not be a pin called ground. It's an external thing to the whole I don't know if you get, again, that will just be useful for the simulation. This is the CMOS inverter here, so I can just go and pick it from the scheme library, so which is not from the Skywater library or the Global Foundry library. So from here So device, so I'm looking for ground, so G and D for ground, then select. So I need several of these grounds, right? So while it's selected, I'll just press C for copy, C for copy, but yeah, so that's it, C for copy. Yeah, but not digital copy actually. Maybe that's a dry joke. So I need to label this node. So this is supposed to be my output, right? So output, or maybe just like what we have in the O and Sodini text, we also want a capacitor, right? Then I can just move this label away first so that I can add the capacitor. Let's me also make the wiring longer. Then so yeah, so I go pick capacitor. At this point here, capacitor, you may want to fabricate the capacitor too, you get. So yeah, if that's the case, you would have to come here to the directory for the PDK. That will be your Skywater PDK. Mine is showing the Global Foundry PDK. I have to come here and search for capacitor. But that capacitor, for this work, there's no intention of fabricating it. It's just there to model. You know, remember I said the CMOS will be in an environment full of capacitive loads. So because this is an inverter, right? Most likely what will be connected to the inverter may be another gates, maybe NAND gates for instance, and the input of a NAND gate you know, is capacitive, because the NAND gate will be made up of what, MOSFETs, right? And the gate of the MOSFET, which will serve as the input for the NAND gate, would be it's capacitive because of, you know, there is oxide capacitor there. So that capacitor, that kind of capacitor we have here, it's just we trying to model the working environment of this guy, this CMOS inverter. So that's why I want to place it here. So we can just say it's for us, it's just for the simulation, right? We don't really want to fabricate. There are times you want to fabricate the transistor, the capacitor. So since it's just for simulation, you know, we just want to pick from the scheme folder directory. So you can just go down there and search for cap. So just the simple capacitor, I think just this, it's okay. No, let's not pick this, just this is fine. It's just for simulation, no much specification on it. So here's our capacitor. So I do the wiring for the ground. It needs to be grounded. So C for copy, remember, but not digital copy. Then I can now bring move, M for move. Yeah, then I can label this so V out. So what should be the value of this capacitor? Right, currently the value of the capacitor is 1p, so that was 1 picofarad, right? So it's left to you. Okay, you may be like, okay, so what's the expectant load, right? So if you know, maybe it's going to be connected to a NAND gate, and maybe you're expecting that the capacitance of that gate would be one value, you just fix it there. So let's say for our own case, let's say it's up to 12 picofarad, let's just say so, or let's say it's up to 10. Let's just use 10 pico. So yeah, that's that for that. So yeah, it seems we're done. Yeah, but one more thing, remember, so you can see the bulk is not wired yet. So from your device physics, what you've learned so far from device physics, the bulk usually of the PMOS, you know, we makes it connected to the highest power. We try to connect to the highest power. Again, your device physics should tell you why. Generally, you don't want a conduction to happen between the source and the bulk. So you don't want there to be any current. So you want to be reverse bias, and yeah, some other, yeah. So you want it to be reverse bias. So to ensure that one way to connect the bulk of the PMOS to the highest power available, so which is the VDD, then the bulk of the NMOS to be connected to the lowest power available, and for a case which is just the ground. So is there any other time that the lowest power may not be ground? Yes, it's possible. For dual supply voltage power rail, for dual supply power rail, there are some, maybe that does not apply here for digital, but maybe for analog you may have, instead of just ground here, you may have a negative supply down here. Most times we want to do that to get more voltage. So if you just have only 2.5 volts and you want more voltage of like 5, up to 5, so instead of, and maybe 5 single voltage is not available, you can use 2.5 for the VDD and use minus 2.5 for the for the VSS. Yeah, but for this case the VSS is ground, just maybe zero reference. Yeah, so I think, yes, for the whole electrical wiring here, I think we're done here. Yeah, and I would just like to check time. I know I have used too much time. Okay, so let me stop here.